Detention system. This is our new edition of the ZeonStorm. Our ZeonStorm comprises of the operation part. This is on the left side is our input data. On the right side, this all panel is our output. Currently, we don't run anything, that's why we don't have any outputs. And on the right bottom is our information tab. It gives some information during run or after run. In order to run our ZeonStorm, first and foremost, you need to enter all the data when I scroll down here until the end. After you enter the all, you only need to click the run to get the output. The computer will compute all the things and do all such of the iteration for you in one run. First part of the data is our rainfall data. Over here we got two conditions. One is a MASMA 2 station, or the other is the others. Others mainly related to our HP1 and HP26. So after you selected your rainfall data, then you go for your duration design. Either you want to have the time intervals by using the TC factors with the factor what you put into it. Then after that one, you can come over there your routing time. How long you want to carry on. Then this is the longest time your computer will run overall. Then after that one, if you got a channel routing, you can go for the masking term routing, where we skip for now. Then from there, you set the pond setting, your freeboard. So our new one, we come with a bump. If you want to have the bump, you must check this box to allow the bump. Then this is the part there, where you want the computer to be end, when the water level reach until 0.01 meter. And at the same time, it also allow a bypass flow. Bear in mind that this bypass flow should not have a very big value to have the pond routing. After the segment on the input there, so we come to the design ARI. This design ARI, you can have a series of design area by adding or removing. Or over here, then you can set your all your AI what you need to have. So from here, when you navigate here, you log into the second group. This is a catchment. So every AI come with a default catchment. So AI 10, there's one catchment. Then AI 50 got another catchment. So when you navigate to the AI 10 years, so this is a catchment data you need to key in for the C value. If you are using the user define, you click on user, then you enter your C value here. Or you want to have your some predefined I value also can. Or what you need to do, you key in your pre-C value, TC, I catchment area, and come with also with a post. So every ARI you need to enter one time. Make sure you have the both data have been entered for 10 years, 50 years for your catchment. If you have to add your own catchment, it's allowed for. You can put additional or remove. After that one, this is a time step where you run into the routing. Over here, by default, we got 4 time steps. By referring to current setting, it will start with the 32 minutes, the first one. Then second is a 1.5 TC, then 2 TC, 2.5 TC. So this is a part later you may need to manipulate by adding more or remove to get your pond sizing. Then this is the inflow. This is a default inflow generated by our catchment. However, you can add your own if you want to. Then we move on. So this is related to channel routing, so we skip on. Then this is another part is quite important for you to do into it. This is the pond sizing. What you need to pay attention is your area of the pond. This is a segmentation, the surface pond area based on the different depth of your pond. 0 here is the base of the pond. Here we're using the 0.5 interval, 1.5, 1, 1.5, 2 until we go for the max here. So every depth there, we need to get our pond surface area to key into here. That's why over here, there's one of the benefit for this program. It can use for any shape for your detention system. After you key in your pond sizing, the next one is for your outlet structure. For our structure, we got a series of outlet structure. one of the newly add-on is a culvert design. So from here, by default, we have the orifice and broadcaster weir. Broadcaster weir is considered as a emergency spillway. Then from here, orifice here, we start with the 0. That means they start on the base of the pond. Then broadcaster weir is start point at the 2.7 meter height from base of pond. So from here, when I navigate there, the below here is a property for the orifice or property of the broadcaster weir. What you need to do, you need to enter the corresponding parameter. After you enter all the data here, our next step, just go for run. That's simple. So the computer will compute everything for you in one go. So what you need to do, you only need to interpret the result. ZeonStorm produce enriched output. It comes with many data and chart. Here are some of the outputs. Now we just focus on the important data routing. So from here, this is a routing result where the computer have been run out. The top one is a numerical method, how they compute. The bottom is a graph that's been presented based on the numerical data. So from here, you can see we got a 10 years ARI, where we got the time step 32, actually the TC, 1.5 TC, 2 TC, 2.5 TC. So every TC, we come with one inflow graph and one outflow graph. At the same time, we got one green color is a water levels. Then there's one blue colors is a pre-queue, where you need to make a control. This is a post max from the program for post development. So from here, we can see that over the red one is the outflow, where it's a control outflow from your pond is much below our queue pre. And at the same time, the water level is about 1 meter plus. So we got 1 TC, 1.5 TC, 2 TC, 2.5 TC. When you observe the hydrograph, the inflow hydrograph, it changes along with your time. This is a type 2, type 1, type 2, or type 3 in the MASMA guideline. So from here, what you need to do, you need to evaluate the result. For example, over here, you got one red color. What this red color means? When you observe this time step, we go for the first one. It gives you some information about the pond. For example, here 32.7 minutes with a volume of pond 14,000 meter cube. Then the time to empty is 890 minutes to reach the 0.01 as defined. Then we will move on second time step 49. So it gives you another pond volume is 15,000. So it also take 920 minutes to reach the volume water level of 0.1. Then 65 minutes there. So it gives you a pond volume of 16,600. Then the times empty is 940, and so up to the last one is about 17,000 of meter cube of the water. So if observed correctly, this volume actually is in the incremental mode. It's still increasing when this time of the storm duration increasing. It gives you a clue that actually these have not reached the maximum pond storage yet. The time step is insufficient. We need to increase more time to check the pond volume until it starts receding. So what you need to do, go back to the input data, scroll down until your inflow case. From here, go for a plus. I can add another time step. That means this one is a 2, this is a 2.5 TC, and so on. So maybe I get 2 until the 3. So before that, there's nothing there. After you key in, the next one, what you need to do, just go for run. Okay, another run. Now you can see after you run, you got 6 time step. But now it turned to green color. Why it come to green color? We just go back to navigate the time step again. So 32, you see 14,000, 15,000, 16,000, close to 17,000, then 100,000, then after that one, it's about 17,000. You see, it shows that the volume actually up to the last one, it start receding. So from there, it give you a clue there. Actually, this time step is given the maximum pond volume for you. So this is the answer for your pond design. It's not what we normally people using 3C as the starting volume. If you compare, you got a much different on the volume where you under design about 3,000 meter cube of the water you never put into consideration. After you get the thing passed, you need to look for another AI. Is it give you the similar scenario? If not there, you need to increase further on so on and get until the maximum volume is reached. So from there, you can a bit interpret a bit more. So over here, when you see the thing, the red one is a control outflow, but the maximum here is about 1.3, but when it allow is a 3.1. It gives you a clue that actually this pond we allow to have more discharge. What we do, we can increase the release water from the pond. There are many ways to do the thing. One of the way there, we go down, scroll down on the input side, we go for outlet structure. We increase the number of the orifice to increase the Q out from the pond. So from there, after I run, this outflow graph should be increased. Let's run. Okay, done. You can see the graph already push up more. So from there, when there are more water coming out, actually the water volume should be reduced in a way. So this is a one on the way you go for the try and error. You play around the input and output data, just evaluate the result until it meets the criteria what we want. Then only we stop our design. This is one of the interesting part because the computer then compute the thing, iterate the thing in one go. It get you the answer. You just play around the input data, get it run, evaluate the result until you get what you need. For example, maybe you want to go a bit more. So from there, this is the profile. It shows the section what you go into it. Let's say I want to have another outlet structures. What I need to do, another orifice. For this orifice, maybe I start from 1 meter height there. Then what I need to do, I just go for another run. So if you compute again, you get another answer. So actually, this is where you can go for try error and play around the output. So from there, now after you run, you can see many table and chart where is presenting for you. So from there, this is your post development without any control. This is a Q post. Then this is the prelim design where you estimated your pond size based on different AI. Then the routing. This is the water level of the pond. For here we got 2 AI, that's why they got 2 charts. So these are storage outflow functions. This is ideal curve. So this is a summary of your storage design. Different AI, different height, then different volume. Then this is the checking for your storage of the pond. It reached the max. After that, we reduce. So we got go into the correct design. Then the profile. Then this is the outlet discharge curve. So from there, we got orifice, we got broadcast area, we got orifice. So this gray color, that means that there's no discharge set. Until you can see here, this is after 1 meter, the water start release from the second orifice. After that one, we scroll down until 2.7, where is your broadcaster area. So we start release of water. So from there, this is outlet discharge curve. We got 3 curve, then plus 1 total. At the same time, they show the maximum Q for you. So this is a part of our STORM program.